Welcome back. All right, continuation from where we stop. Okay, we'll be talking about what? The series combination of the what? Resistance, inductance, and capacitance in an AC circuit. Okay, we know that in this case, the same current flows through these circuit components, but the voltage are what? Different. The potential difference across them are what? Different. Okay, it is very simple to evaluate. So we are looking for what? The effective voltage across the three of them. So this is clear. You can say that this is the voltage across the what? Resistor, voltage across the what? Inductor, and voltage across the capacitor. Of course, these two, they are what? Perpendicular to each other. While these two, they are what? Perpendicular to each other, 90 degree, 90 degree, perpendicular to each other. And the voltage across the what? Inductor and voltage across the capacitor, they are 180 degree apart. In what? Different, in opposite what? Direction. First, to get the effective voltage across this, first we resolve this. This is a vector field. First we resolve this. We can say that it's going to look like this. This is V subscript, taking the what? The positive difference, V subscript L minus what? V subscript C. Then this is what? V subscript what? R, perpendicular to each other. First we subtract these two to get the what? The effective voltage, in the sense that V subscript L is greater than what? V subscript C. That is when this is what? Effective. If C is greater, V subscript C is greater than V subscript L, you do the reverse. It's very simple. Okay. Now, getting the what? The effective voltage across it using triangular law of vector, Pythagoras theorem is very easy. So this will become V squared equals to what? V subscript L minus V subscript C raised to the power of 2 minus what? Sorry, plus what? V subscript R raised to the power of 2. So therefore, the current that flows through them are what? The same. Just factorize the current. So V squared is equals to what? I bracket what? V subscript L squared. This is what? V subscript L minus V subscript C plus what? V subscript R. Let me put it in a still brackets. So this is square, this is what? Square. Okay, just evaluate. We have it that, no, we didn't take, we didn't use the other formats. Converting them, this is what? I square. We have, this is, all over here is what? X subscript L minus what? X subscript what? C. Then plus what? Arrow to the power of 2. So using what? The nasty brackets. Okay, it's going to look like this. So this becomes the what? This becomes what? The impedance. Let us take the square root of both sides. Taking the square root of both sides, this is what? I. Then what? Square roots X subscript L minus what? X subscript C is the power of 2 plus R is the power of 2. So everything here becomes what? The impedance. So everything here becomes the impedance. So that is the impedance, which is Z is equals to V over I, which is equals to square roots X subscript L minus what? X subscript C is the power of 2 plus what? R is the power of 2. And this is what? The impedance. Make sure you take this thing down. Take it down. We are just taking formulas. In our next class, we are going to evaluate problems using what? What we have learned so far. From my previous video, this one, and so on and so on. Okay. Guess we are done with the series connection. Okay, you can pause the video and take it down. This is the impedance in this case. You know that we have different impedance. Impedance is the what? The opposition of currents offered by combination of what circuit elements. Circuit element in an AC circuit. It depends. It's always changing, but you have to know these things. Okay, now let's discuss resonance. The resonance. Let me put it right here. Resonance in what? ROLC series combination. Now, when we discuss resonance in the sense that this thing occur when the maximum current is what? Obtained from the circuit. When the maximum current is what? Obtained for the circuit. And for that maximum current to be obtained from the circuit, it means that the impedance, must be what? Minimal. Must be minimal. In the sense that if we know that from Ohm's law, V is equals to what? IR. So therefore, this is, in this case, that is V is equals to what? RZ, impedance. Impedance is measured in ohms. That is the opposition of currents, that's the opposition of currents in the what? The ROCL what? Series, AC circuit. So this is what? The impedance. Now, this impedance is equals to what? V over what? The current. That is, we can say that the impedance is inversely proportional to the what? Currents. That means if the impedance decrease, the current will do what? Increase. Impedance is what? Opposition to the flow of what? Current. If the impedance decrease, current will do what? Increase. That is, for resonance to occur, it means that we have the what? The maximum current can easily be what? Obtained. And for that maximum current to be obtained, that is the impedance, which is the opposition to the flow of current, must be what? Minimal. It must be minimal. So, I hope you are taking this thing down. For that to be so, we can say that the what? The inductive reactance, that is, the inductive reactance is going to be equals to, for that to happen, the inductive reactance will be equals to the what? The capacitive reactance. Because these are the what? Are the opposition to the flow of current offered by the inductor and what? Capacitor. So the inductive reactance is equals to what? The capacitive what? Reactance for resonance to take place. And it occurs at a resonant frequency. The frequency at which it occurs is known as what? The resonant frequency. And this, the inductive reactance is what? 2 pi FL, which is equals to, this is what? 1 over what? 2 pi FC. We have done this in our previous class. You can always check it and go back to your studies. We get everything. Okay. Now, if this is true, we can easily say that for resonance to occur, at what frequency it occurs? It occurs at what? Resonant frequency. So for resonant frequency, let's use F naught for resonant frequency. That is for these two to be equals to each other. At what frequency should this happen? At what? Resonant frequency. So let's use F naught at resonant frequency. So if we cross multiply, we have it that when we cross multiply, this will be what? 4 pi raised to the power of 2, F raised to the power of 2, then LC equals to what? 1. LC equals to 1. Okay, then if we take the square root of both sides, taking square root of both sides, we have it that this is what? 2 pi, taking square root of both sides, F square root of LC equals to what? 1, taking square root of both sides. So making the what? F naught, resonance frequency. Making F naught subject formula, the resonance frequency is going to be what? 1 all over what? 2 pi square root LC. Now this is what? The resonance frequency. Please take note of that. Okay. Now, the angular velocity at which this occur, which is, we call it what? The angular speed at which we have the resonant frequency, that is what? 2 pi f what? F naught. And if I make the resonant frequency here subject formula, resonant frequency will be equals to what? Angular speed over what? 2 pi. Angular speed over what? 2 pi. So we can also put it here that angular speed over 2 pi is equals to, this is what? Resonant frequency, which is what? Angular speed over 2 pi is equals to what? 1 all over what? 2 pi square root LC. Can see what I'm doing? So therefore, if I make this subject formula, this is equals to 2 pi over what? 2 pi square root LC. Making this subject formula is just to multiply both sides by 2 pi. Multiply both sides by 2 pi. 2 pi cancel 2 pi. I have this. So I have this. So therefore, 2 pi will also cancel out 2 pi. You know, the same thing. Then this is equals to what? 1 all over what? 1 all over what? Square root LC. So this is the what? Angular speed at which it occurs. Resonant frequency. Resonant what? Resonant in what? RLC series circuit. You can see how simple it is. This is when the maximum, that's the maximum current has been what? Obtained. Please stay tuned. In our next class, we are going to execute problems relative to this. We are taking problems on what? SSC, that is NECO, WAEC, GC, both WAEC and GC, NECO GC, WAEC GC, and so on. Then UTME questions relative to what? AC circuit. Please stay tuned and make sure you subscribe to my YouTube channel for more. If you are a student, that is a channel for you. Please just be there. Just be there. Okay. I think we are done for today. In our next class, we hit questions so hard. Thank you and God bless you.